Lastly, another way of thinking about categorizing our data is the levels of measurement approach. When you think about how data are collected, there's a natural level of complexity about the measurement that we're taking. And let's just run through these 4 levels that, this is one specific take on levels of measurement. There's others, but this is the one that's most useful to us and is introduced most commonly in other statistics class. Namely, nominal, ordinal, interval, and ratio level of measurement. So what we call nominal is basically the idea of categorical data that is just names and labels, and they cannot be ordered. You cannot ascribe a natural order to them, or you can, but you're choosing not to. So for instance, addresses, names, if the name of the medications you're taking, all of that would be measured at the nominal level. Or ethnicity, right? The ordinal level builds on the nominal level in the sense that you can order. So ordinal, order, right? Nominal, name, nom. Ordinal level of measurement means that you can order your labels, your names, but you cannot take differences. Your differences are meaningless. Another good example is Olympic medals, right? So for any competition, event, you have somebody taking gold, taking silver, and taking bronze. That there's no information you can glean from that is actually measuring whether a bronze is twice as good as not winning, or a silver is twice as good as bronze. That part doesn't matter. What matters is that gold goes first, silver goes second, and bronze goes third. So you're gonna notice a pattern here where we're building on the previous level of measurement, and the next one is interval level of measurement. So with interval level, you can take differences. These are meaningful things that we can do with interval level data, but there's no sense of what we call a zero or fractions. A good example is years, right? So so the year that a house was built. For instance, if you live in a house that was built in 1994, that you can take differences in terms of, this house was built between 1980 and 2000, which is a difference of 20 years. But there's no way to say, this year, this house was built on a year twice as great as this other house. And that's where we get the last amount of complexity that we can gain from our data, which is the ratio level of measurement. So here we have a natural starting point, a 0, and we can take ratios, which is why we have the name ratio. So a good example is income, for instance. You take a population of people, of U.S. workers, and you can reasonably ask the question, does this person make twice as much per year as this other person? And that is an example of the sense of the twice as much test. So we'll call that the twice as much test, which is a way of distinguishing between interval and ratio data, because it's hard. Sometimes it's really hard to tell the difference between those two levels of measurement and whether your data are collected at either one. The twice as much test is, can you ask the question, is X twice as much as Y for your data? And so for income, for instance, that makes sense. For number of children in the household, that makes sense. But for years, that doesn't make sense. You can't ask, is 2020 twice as much as 1010? That just doesn't make sense. And one more relationship between the levels of measurement and the other kinds of categorization that we had is that nominal and ordinal tend to correspond to categorical data. Names, labels, even if there's an order to them, they can be classified in terms of these levels of measurement, whereas interval and ratio, we are generally talking about quantitative data. And you'll notice that in the examples that I provided. Regardless, there's a order between the levels of measurement. As you're going down, you are increasing the complexity of your data. You get more information from them. And as we move through the next few chapters, we're going to talk about how certain measurements, so in other words, statistics and parameters, make sense only for certain kinds of levels of measurement. It makes sense to take an average or a mean of data collected at the interval and ratio level, but not at the nominal and ordinal level. And this will make more sense in context once we get to those.